Oh man, it's hot outside. Hey, what are you cooking?
Some pad thai.
That's not like any pad thai I've ever seen.
Hi, I'm Gabe,
And I'm Kevin.
and this is the Portable Accurate Weather Logging Device, or padTI.
So what is the pad thai exactly? Pad thai is the BoosterPack entry for the 2012 TI design competition.
Because of the small form factor and ultra-low power capabilities of the MSP430, we decided a useful but versatile booster pack would be a weather logging device.
We developed this pad thai with the idea that the open source and hobbyist communities would grab on and appreciate the BoosterPack because of its versatile application. Pad thai can run both standalone or be incorporated into other designs.
We can see hobbyists and makers alike using padTI in their own projects, ranging from distributed weather gathering to avionics and rocketry.
Pad thai allows users to keep real-time data about the environment using humidity, temperature, and barometric sensors. In addition, there's an onboard micro SD card slot to allow for long-term data logging capabilities.
So the idea behind a booster pack is not only to get full function out of it, but to be able to use other booster packs in your complicated projects. So when we were taking these considerations during our design process, we decided that all our sensors should be on I2C and our SD card would be using the SPI interface. We use UART communication to talk to our GUI, and those are also shared on the same module that SPI uses. I2C is also based on another hardware module developed inside the MSP430. Because we can stack all these sensors together, other I2C devices can be shared on the same bus, and those devices can communicate with the SD card if you want to. We made some special considerations when we were laying everything out. There are some holes around all these sensors to allow for airflow to get most accurate data out of our sensors. There's also headers so we can debug and control I2C communications, and on the back of the board we have some mounting holes for a coin cell battery that allows the unit to operate completely tetherless.
So we added a lot of capabilities for debugging. The first and foremost aspect was the amount of jumpers we have on the board. Each of these connect to a different sensor and allow for us to be able to, with our handy sniffer, to sniff out the I2C lines and see what each sensor is communicating if it's acknowledging the MSP430. In addition, it was difficult to make the I2C and UART libraries. It was hard to find them online, at least examples of them, and the MSP430 example code is not the greatest. So in making this project, we ended up making a sort of combined I2C UART library that other users could incorporate into their projects. Lastly, there is a LED on the launchpad itself, which will turn on whenever a UART character is received from the computer.
So this is the GUI for the padTI. You can see it's built in MATLAB and is fully resizable for whatever needs you have. Now right here is where you choose what COM port your MSP430 communicates over UART. Our MSP430 talks over COM port 9. To enable communications, you just press the toggle port button. If everything's successful, the enable update checkbox will pop up. Here you adjust the update rate in seconds, and here you adjust the buffer size in number of variables. Here you can choose what goes on each axis. You have humidity, temperature, time, and humidity and temperature, and the y-axis has the same options. Let's go ahead and check out time and temperature. We'll start collecting data by pressing enable update. Here's a screenshot of some log data from padTI.
Dude, that was terrible. I'm gonna go eat real pad thai.